Okay, so our first lesson today is on page 5 in your notes packet. So make sure you are open to page number
Main office,
5.
Ms. Handy.
And we are talking about exponential functions, which are non-linear functions. So we've talked about linear functions, which are straight lines. We've talked about quadratic functions, which are those parabolas, those U-shapes. So on page 5, we start with our opener. And we're talking about a little bit of science. We're talking about cell division. So it says cell division is a basic property of living cells. In cell division, each parent cell produces 2 or more daughter cells. Consider cell division in which each parent cell produces 2 daughter cells. So when none of them have divided, we have 1 cell. So here's my 1 cell. When this cell divides, it's going to divide into 2 daughter cells. So 1 division is going to give me 2 cells. Each of my 2 cells are then going to further divide into 2 more cells. So at 2 divisions, I have 1, 2, 3, 4 cells. Each one of these is going to divide into 2 more cells. So 3 divisions is going to give me 1, 2, 3, 4, 5, 6, 7, and 8 cells. So now for me to draw for 4 divisions would take up a lot of space. But now I'm going to think, can I find a pattern? With linear, our pattern is either adding or subtracting. Well, 1 plus 1 is 2, but 2 plus 1 is not 4. So I know I can't be adding. So I'm thinking about it. Oh, I can multiply. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So 8 times 2 is 16. Makes sense. So now graph the data from your table on the graph provided. Okay, I noticed some of the numbers are missing, and we know that's a trap for us. Why don't we actually number each and every one so I can see exactly where I should be putting these dots? Remember, if at any point in time I am moving too fast, you can pause it, you can re-watch, but I'm just going to keep going. So 0 gives me 1 cell, 1 division gives me 2, 2 gives me 4, 3 gives me 8, 4 gives me 16. Right off the bat, I'm going to notice something about this data. And I'm going to say it's not a linear function. I know from the table that it's not a linear function because if it was linear, we would have to add or subtract every single time. But I am not. I am multiplying. So we are not adding or subtracting. I know that it's not linear by looking at the graph because it's not a straight line. What patterns did we notice when watching the animation? Well, the pattern is the cell divides into 2. After how many divisions will the number of cells be 16? Well, that's easy. On my table, I'm going to look at 16. Next to 16 is 4. And that's because we're going to look where y is 16. The next one is kind of tricky. It says how many cells will be present after 5 divisions? How did you figure this out? So now look at your table and look at your graph and see if you can figure out how many cells would there be after 5 divisions. So you should have noticed that there was a problem with that. The problem with that is we don't have 5 divisions in our graph. We don't have 5 divisions in our table. But there is something that we know. What we know is, well, I could do the math. If I want to add 5 divisions, I would do 16 times 2, which is 32. And then how did we do that? Oh, sorry, 32 cells. How did we figure this out? We continued the table. Pause if you need to, otherwise let's flip it. Okay, so it says some cells divide into 3 cells at a time. Fill out the table to show the number of cells after each division. Then make a graph of the data. So now this one's going to be fun. I got my cell. It's going to break up into 3. 1 and 3. Each one of these is going to break up into 3. One, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if we can figure out the pattern. Well, the last one we were multiplying by 2 because it's split up into 2. This one makes sense. We're going to multiply by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So now let's make our graph. Missing numbers. I'm going to fill those in briefly. 1, 2, 3, 4, 5, 6, 9. 2, 3, 4, 5, 6, 7, 8, 9, 11. So on and so forth. 0 is 1. 1 is 3. 2 is 9. 3 is 27. Again, we see a nonlinear function. We see this exponential function because we are multiplying, we're not adding or subtracting. So these questions should be very easy. I would really like for you to pause the video and try to answer these before you keep watching. So after how many divisions will the number of cells be 27? 3 divisions. Sorry guys, still in school. How can you use the table to figure this out? Well, we're going to look at where y is 27. How can you use the graph? Same exact thing. If I go where y is 27, I'm going to find my point. What pattern do we notice on the way the cells divide? Well, this time, the pattern is it divides by 3. We call that tripling. is this table similar to the table from the opener? So for similar, I'm going to put S. And then I'm also going to say, how is it different? So if I look at how they're similar, those tables, the first one, I was multiplying by 2, right? The second one, I was multiplying by 3. One thing right there I just said twice, and that was that both are multiplying. The difference I also said in that same sentence. One was multiplying by 2, the other was multiplying by 3. How are the graphs similar? How are they different? Well, both of them are similar because they're both nonlinear, meaning not lines. But they're different because they have different plots or different points. Which we call that the steepness. So if you need to, you can pause the video from here. What you should be doing at this point is you should be doing this homework packet with it. You should be doing just the first page, the lesson 4 homework.